Hey there, my friends. Wanted to give you an update that I promised some of you about the storm that was on the south end of Colorado Springs last Thursday. This was the storm that took all of those trees down. This was near the area of the Valley High Golf Course in the vicinity of Airport and Shelton, kind of on the south end of town. And you can see some pretty big trees came down. Now, I will say that the ground being wet certainly had something to do with it. But it also takes some really strong wind to do that. And you see some of the issues that were out there cleaning up last Friday morning. Here are two radar images, and they're actually sort of one radar image, but two different data sets from the same time. On the left-hand side, you see the reflectivity. That's what we always show you. This is a simple measure of the radar energy that's returned to the radar when it hits things in the atmosphere. So, the more raindrops there are, the bigger raindrops, those will return more energy than just a drizzle. Hail returns more energy than rain. It also picks up dust and bugs when there aren't any storms around. But you can see this was an intense storm, and just for some reference here, it was moving from northwest to southeast across the region. Where this little triangle is about in the vicinity of Airport and Shelton. And so if I come over here, you see that same triangle. There's some red colors and some green colors. This is velocity. This uses the Doppler effect to measure along the radar beam if the wind is moving toward or away from the radar. That's all it can tell, is motion along the beam. And so what you see here is what we call a divergent wind pattern, because sort of on the front side of the storm, you see green here, which means the wind is moving from northwest to southeast toward the radar site, which is off to the bottom right of the picture here because it's in northeastern Pueblo County, off to the southeast of the Springs. On the back side of the storm, you see red colors, which shows us that the wind is moving away from the radar. And so that's moving from southeast to northwest. This flow is away from each other. What this tells me right here is that we had a downdraft happening sort of on the rear flank of the storm. Now, there are some other, we're kind of watching between 5:30 and 6 o'clock here was when all of this happened. And there were some other radar looks there that made it pretty clear that the storm was rotating. This shot I got certainly shows that here. You see this striation in the cloud. But this was the best shot that I saw from a photo perspective from Kay Sargent, and thanks for sending this to me. This is off to the southeast of the storm, and it was a pretty good storm as it moved into the area. What you're seeing right here is the rain-free base of the storm. You can tell by the crispness of the clouds here, there's no raindrops, sort of making that smooth looking like it is back behind it here. That's the core of the storm and the intensity that you were seeing on the reflectivity of the radar that I showed you. But on the south end of the storm, see this dark edge of the clouds here, and then it gets brighter back behind it? This is what we call a rear flank downdraft. That's visually how we see those in the storms, and you can see that there's no rain back in there. This is where the air is accelerating down on the back side of the storm and then kind of rotating around toward the front end, and there is a little hanging, lower hanging there as the storm is rotating, and then this is what we call the inflow notch. And so the inflow into the storm is kind of from outside of the screen pointing back toward the rain-free base there, and then this is the updraft going this way. So all the pieces were there of a storm that was rotating. But when I saw this picture, along with the radar that I saw, I was probably like, as I was doing the forensic meteorology and building the story, this probably wasn't a tornado. Now, the storm I don't think was too far off from maybe producing one if it was a little bit stronger. But you'll see the downdraft in this video here. This is a ring video, and these things are great. I posted one yesterday of some bears in my neighborhood. This one is from that area, and kind of watch up on the top right-hand corner of the screen. There's 25 seconds left. You'll see the wind picking up, And unfortunately, the power went out at this location right as the really strong wind gust was happening. See some things starting to blow around here. The rain's starting to go sideways. And then we've got 10 seconds left. Right at the end, watch the wind kind of accelerate into the camera here. Boom. Right there. That was the downdraft, the intensity of the gusts that caused the issues and brought those trees down last week. So rotation was evident on this storm. We saw that in the velocity, some of the other velocities that I didn't show you in particular, and your photo imagery and evidence that you submitted as we sort of built this scientific picture together. But what's most likely is that it was the rear flank downdraft. And these things can certainly be strong enough to produce damage when the conditions are right, like we saw last Thursday in Colorado Springs. And I'll say this, if you had trees down on your house, does it matter if it was a tornado or a downdraft? I would say probably not.